This screencast is all about the elimination method. So we have talked about solving systems by graphing the two lines and finding the point of intersection. And then we also talked about the substitution method, or you might be familiar with the equal values method. So in this screencast, we're going to look at the elimination method. So this is best to use when x and y are together on the same side of the equation. So we're going to take a look, we're going to call this example 1, but this is from the note packet. It is number 53, so you should also fill this out with your notes. So looking at the two equations, we have 3y plus 2x equals -2, negative 3y plus 5x equals 16. Well, the first thing we're going to do, because we're not going to substitute, we don't have a variable that is by itself, is we're going to see, can we just add these together and will something eliminate? So I'm going to add my first and my second equation together. So 3y plus negative 3y eliminates, which is what we wanted to happen. 2x and 5x give me 7x. Negative 2 plus 16 is 14. So now we can solve for x, divide both sides by 7, so x is equal to 2. Remember, we are not done just yet. We have to find out what y also equals, so we're going to plug this back into one of the two equations. It does not matter which one you use. I always try to look for the one that is, the least amount of work when you go to plug it back in. So for me, I'm going to say that's probably the first equation. So I'm going to take my 3y plus my 2x, but instead of x, I'm now going to substitute in my 2 and then bring down or include my equals -2. So we can solve for y. So 3y plus 4 equals -2. Subtract 4 on both sides to get 3y equals -6, and then divide both sides by 3. So y is going to equal -2. We will write the answer as an ordered pair, so we will have 2, -2. And it's always a good idea to double check, plug them back in to make sure they both work for both equations. Example 2, we are going to solve for x and y, and this is number 55 from the note packet. We have 2x plus 7y equals 13, 2x plus 3y equals 5. So like last problem, we're going to see if we can add these together to see if something cancels out. So if we add them, we'll get 4x plus 10y equals 18. So nothing eliminates. We still have our x's, we still have our y's, so I'm going to erase that. So we can't just add them the way they are. So we have to do a couple of extra different steps. So looking at the variables, we want to see which one would be the easiest to eliminate. So it's always a good idea to look to see what variable already has the same number coefficient. So in this case, I'm looking at my x's. They're both 2x. Now, when we add them, they don't eliminate. So what we're going to do is we're going to multiply the bottom one by -1. So everything in that bottom equation is going to be multiplied by a -1. The top equation is going to stay the same. So 2x plus 7y equals 13. Now we have -2x minus 3y equals -5. We can then add them together, and our x's will eliminate. So we can have our 4y equals our 8. So from here, we're going to divide both sides by 4 to get y equals 2. So we solved for y. Now we have to go back and plug it in and find our x. And again, it does not matter which one you plug it into. I'm going to plug it into the bottom equation this time. So I'm going to have 2x plus 3y, which will be 3 times 2, equals 5. So 2x plus 6 equals 5. Solve for x, so we're going to have to subtract 6 on both sides. 2x equals -1, and then we'll divide both sides by 2. So x is going to be -1/2, and y is 2. So we're going to write that as an ordered pair. And again, it's always a good idea to go back and make sure that the left and the right sides of both equations are equal. Example 3 is number 56D from the note packet. 7x plus 4y equals 17. 3x minus 2y equals negative 15. So again, we're looking at our variables, which one we want to eliminate first. If I look at my x's, I have a 7x and a 3x. They don't really have anything in common, and nothing easily could cancel out. We can multiply to eliminate. So I'm going to focus on my y's. I have a positive 4y and a negative 2y. Well, remember, the goal is to get them to be the same coefficient but opposite signs. So we already have a plus and a minus. Now we have to somehow change this bottom equation to make it a negative 4y. So going from negative 2y, we can multiply the whole thing by 2. So the top equation is going to stay the same, but the bottom equation we're going to multiply the whole thing by 2. That way our negative 2y becomes a negative 4y, and when we go to solve, the y's will cancel out. So we'll have 13x is equal to negative 13. We can now solve for x and divide both sides by 13 to get x equals negative 1. So we need to go back and plug this in one of the equations so that we can solve for y. I'm going to plug it back into the first equation. So that was 7x plus 4y equals 17. So instead of an x, I'm going to take that out, and I'm going to substitute in my negative 1. So negative 7 plus 4y equals 17. And then we can solve for y. Add 7 to both sides. 4y equals 24. And then divide both sides by 4. So y is equal to 6. So our solution is going to be negative 1, 6.